Hey, this is Passy from Passy's World of ICT, the guy with the... Hang on, I gotta search for my hat. I'll check over this side of the desk. No, it's not on that half. Let me check over the other side of the desk. Ah, there it is. And that, my friends, was a binary search. Okay, thanks for watching and we'll see you next... No, just kidding. Let's go and get into it. So that was actually a quick demonstration of a binary search. So in our previous lesson, when we had our tennis dream team, arrays lesson, which you should have done already if you've been following along with the course, we had a search function. So we were displaying what was in the array here. And if you searched for Bernarda and clicked on Find Player, it would tell you Bernarda is a member of the team, the dream team, because it found her in the list of people in the array. So that's a linear search. And look, they're great when you don't have a lot of data to search for, and it's very simple algorithm and easy to code. So that's definitely the way to go. But when you've got a very large array, like say the top 1,000 tennis players in the world, and Bernarda was kind of, you know, right along in that array at number 750, that means you've got to search along 749 other people working from the start to where she is, which is very inefficient and would take a long time. Binary search is a lot quicker. So for very large arrays, binary search. So when I was working at the bank, you know, where they've got millions of customers on their database, you know, everything had to be searched for with binary searches. There was no way you're going to run some linear search and wait for, you know, like 10 or 15 minutes for it to find some customer, okay? So binary search is really important thing when you're doing programming. The other important thing is that a binary search always requires that your data has been sorted, either from lowest to highest numbers or in alphabetical order if it's names or strings. So if you've ever played this higher and lower guessing game, and we had the algorithm for this way back in the algorithms lesson at the start of the course, and actually showed you how to make a program to make a little guessing game. And it's the binary search method that's used. So if we're playing that higher or lower game, and it's guessing a number between 100. So the computer's got a number between 100 that it's guessed. The very best guess you can put is the halfway point between 1 and 100, which would be 50. You'd click that button and then the computer's telling you that's too high. So if you know 50 is too big, well then you know 60 is too big, 70 is too big, 88 is too big. You can discount or discard and ignore all of the numbers from 50 up to 100 and just focus now on the numbers from 1 to 49, okay? So we can ignore the upper range, and if we add 1 plus 49 together, we get 50, and if we divide by 2, the halfway point is 25, so our next guess should be 25. So let's say we did that and the computer told us that number was too low. Well, then we know, okay, well, it must be somewhere between 26 and 49. So by doing halfway guessing, binary has to do with 2. So dividing by 2 each time and going halfway, our next guess, you'd either do 37 or 38, because it kind of came out 37.5 for the exact halfway point. And you'd keep doing that until you guess the number, and that is the most efficient way of doing it. And you have to remember, a computer has no brain, it only does what you tell it to do, and it has no eyes to see things either. So it has to do it by this kind of binary search routine to find things, and that's what we're looking at in this lesson. Okay, so the main steps in that binary search that we were doing, first thing is you have to have your items sorted into ascending order in your array, in your program. Now, sorting's a whole nother world, and we're going to do that in another lesson. So the ones in today will already have them sorted in order, but if you're just getting random data from somewhere, you would need to sort it before you did the binary search. Now, step number 2, take your number of array items, how many items are there, like when we had 1 to 100, there are 100 items, divide it by 2 to get the halfway point, which was like 50, and that's your first point of where you should be searching for things. Step 3, the search for value, if it's less than, work out if it's less than or greater than that halfway middle value, and then you can work out, okay, there's half of this stuff I can just totally ignore, like when my hat wasn't on that side of the desk, I knew, well, I can forget about that side and concentrate on the other half of the desk to looking for my hat. So you're doing halves by halves by halves and eliminating. Step 4, Step 5 is you just keep repeating those 2 steps, steps 2, 3, and 4, those 3 steps. You keep repeating them until you've either found what you're looking for, or you might just be at the end of the searching. You can't go in half anymore, and you've finished. And the result is that that item was not found. So binary searching is really fast. And just usually in just a few comparisons, we can find the thing that we're looking for. So it doesn't take that many steps. So we call each step a kind of a process or a pass. We call it a pass. We've passed through the data once looking for things. When we cut it in half again, it's called pass number 2 and pass number 3, pass number 4, and so on. Okay, so these steps might not probably make any sense at the moment. But I can assure you by the end of this lesson, with all the examples we're going to give you, this should all make sense and be easily understandable. And what we're showing you in this first part of the video isn't just necessarily for Visual Basic. We're just going to give you a general algorithm. You could use this if you're a Python programmer, if you were writing this in JavaScript. It's still the same logic, so it's still going to be the same algorithm, okay? In the second half of the video, of course, naturally, we're going to do Visual Basic specific code. But, you know, the first part of this is applicable to all programmers wanting to do a binary search of a very large data set. Okay, let's just show you the algorithm. That's what it looks like. And you're probably looking at that going, oh, gee, there's a lot of stuff there. And I bet if I came and took a photo of you, you'd probably look like the 2 people in that picture. Just, oh no, that looks way too hard. Yeah, and it does. Like, you don't kind of look at a process and go, oh yeah, I'll just sit here and type out the algorithm straight away. You usually have to do some thinking, a bit of working out with pen and paper, trying a few things out, maybe even just writing a few bits of code and testing them before you can put the whole kind of jigsaw puzzle, the algorithm together. So that's what we're going to do first. We're going to do some tracing and work out some things manually and see how this whole kind of binary search thing works. And then we can come back and work out the exact algorithm we need to put it into a computer language. So let's manually work through an example of a sorted array we're going to have here. We'll just do the first 11 prime numbers. Now, you might not remember what prime numbers are, but in maths, they were the ones where they only divide by themselves and by 1. So we're looking at like 1, 3, 5, 7, skip 9 because that can divide by 3, 11. Anyway, you don't have to know that. All you have to know is these are the numbers: 1, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. And we're going to be looking for 23 just for this example. So our numbers are there on the right in that column where it says value. And we also put the index of the array, their location in the array here on the left. And remember, in Visual Basic, indexes start at 0. And then they go upwards from there by 1s. So even though there's 11 things in here, we start at 0 and we end at 10. There are 11 things. So to work out that top index of 10, you just go, okay, the length of the array is 11 items, 11 minus 1 is 10. So that should be familiar from all the programming work we've done so far in the course. And so the initial search length is we've got 11 items there to look at to try and find our 23. And you're probably thinking at this stage, well, that's stupid. I can just look at that thing and I can see 23 straight away. There it is. Like it's the third one up from the bottom. But you got to remember the computer has no eyes. Our eyes are such a great gift that humans have, and it doesn't have much of a brain either. So we've got to have this step-by-step sort of process of doing it. So this is going to be search pass number 1. So we work out the lowest index and the highest index, 0 and 10. And what you do is you sort of work out the average of them, but you go 10, the highest one here, plus the lowest one, 0, and we divide that by 2. So we've done a little sum here, 10 plus 0 divided by 2, 10 divided by 2, that equals 5. So that tells us the exact middle of this array of numbers here, this little set of drawers or boxes where we're storing things, is position 5 here. So we're working on the index first, and we've got position 5. Now, our next step is to see what is at position 5. Well, at position 5 stored in that array, box number 5 here, is the number 13. Now, how does 13 compare with this 23 that we're looking for? Well, 13 is less than 23, okay? So because of that, if we think about it, okay, 13 is less than 23. So basically all these other numbers that come before 13, they're going to be even smaller again. So they're absolutely useless. So what we can do is we can just get rid of this whole bottom half. And that's kind of what we're going to do next. So what we do is 13 and all these other ones which are smaller than it because of the sorting order, let's just get rid of them straight away and ignore them. Now how we do that is we do it by moving our index positions around for the low and the high value. So we only want to look at these other positions here, 6 to 10. We've eliminated 0 to 5 positions. They're no good. They're all little numbers that are way too small, nowhere near the 23 that we're trying to get to. So we're going to look at positions 6 and 10 in this area here. And this is going to be our second pass, search pass 2. And what we've done with the index is, the low index is now 6. All right, so our index was at 5. But we're adding 1 on to where we were and setting the low index at 6. That's the beginning of this area we need to search. And our high index is still the end of the array, number 10. So you've probably guessed what we're going to do next. We're going to add those two guys together and divide by 2. So the middle index, 10 plus 6 divided by 2 is 8. So the middle of that whole area that we still need to search is at position 8. But it's not the value 8, that's just with the location. The value in there, hey, wow, the value's 23. That's the one we were looking for. So in 2 passes, we've actually found our 23. So that was kind of really lucky, a really good example. And now if you compare that with the linear search, we would have just started at the beginning and gone, oh, 1, is 1 equal to 23? No, let's go on to the next one. 3, is 3 equal to 23? No. 5, 7, we would have done 1, 2, 3, 4, 5, 6, 7, 8, 9 passes or 9 checks to get there. But with the binary search, we did it in 2 checks. So that's why binary search is a lot quicker. Now, in terms of computer speed and processing, look, you wouldn't bother doing it on something this small, just an array of 11 items, 0 to 10. But look, in bigger things, yeah, you have to use binary, and that's why it is so important. Now, let's look at a second example where we've got an even number of array items and we're searching for the value 2, because this gets a little bit trickier. Here we've got just the even numbers. We've gone 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we've just done the first 10 even numbers, but because of Visual Basic, the first index or the first box that things are stored in is box number 0, and the last one is number 9. And you're thinking, 9? But hang on, there were 10 of them. Remember, you do the length of the thing minus 1. You should be getting really used to that at the moment. So I got 10 items, which is an even number, and that's going to have some impact and significance, as we'll see very quickly. All right, so in search pass number 1, we're just adding together our low and our high index, our 0 and our 9, and dividing them by 2. When we do that, we do 0 plus 9 and divide by 2. We get a bit of an ugly answer here, 4.5. Now 4.5, how are we going to find that location? Well, it's not at 4, it's not at 5, it's kind of in between here on this line, which kind of like isn't even a value. So the middle index is 4.5. That doesn't line up with a definite position in the array. So we've put that 4.5 though in our program in Visual Basic. We're going to put it into a field variable that's dimensioned as an integer. All right, not as a double, as an integer, which means Visual Basic will kind of truncate it off and remove the 0.5 and just make it 4. So, you know, when it comes out 4.5, we could either go to 4 or we could round up and go to 5. We're just going to truncate, just take the 0.5 off there and get rid of it and just have the 4. So we're going to go to position 4, and that's where we're going to be for pass number 2. Okay, so search pass 1, just continuing that. We're going to decide we're going to position 4. So 4.5, we just take the 5 off, the 0.5, and we go to 4. Now at position 4, index number 4, we've got the value 10. Now how does 10 compare with this 2 we're looking for? Well, 10 is bigger than 2. So that means all these other numbers like 12, 14, 16, 18, we know because that's sorted, anything past 10, anything with these high index numbers here is going to be way too big. So those ones we can just totally forget about, cross them off, and we're down to now looking at just the top half of this array. So that's why binary search is so good. After your first check, you can pretty much eliminate half of the things and only be looking at half of what you originally had. So that's where the speed comes from and makes it quick. Now, with that, because all these we're not looking at, the new high index, and in your program you'll have to set that, instead of the the end of the searching being right down the bottom. The end of the searching now is located here, which is index number 3. So the new high index is 3. Okay, so that's search pass 1 finished, and let's get on to see what happens in pass number 2. So remember, we're still searching for this number 2. In pass 1, we checked right in the middle of here, which was 4.5, but we just took it down to 4, checked it out. 10 and all these numbers are way too big because they're way bigger than 2. So we're just looking at this bottom half, low index 0, high index 3, search pass number 2, add those together. 0 plus 3 divided by 2 is 1.5. Get rid of the 0.5. We need to go and look in index position 1. So that's what we're doing in search pass 2. And we check that out and we see we've got the value 4. Now the value 4 is still bigger than 2. So that we know that anything past this index position, like position 2, 3, 4, 5, 6, we know they're all too big. And so these guys here, we know are too big because they're further along in the indexes. Remember, everything is sorted into small going to big. So we can cross off all of those plus the 4. The 4 is no good because that doesn't equal 2. And my goodness, we must be so close to being there. Maybe we have to only do one more search pass. Anyway, let's see how we go here. So the low index is at 0, and we've crossed everything off and moved our high index up 1. And so it's now at 0 as well. So both of them are at 0. So when we do search pass 3 and add those together and divide by 2, 0 plus 0 divided by 2 is just 0, which tells us we must be located here. And when we check out what's in there, yeah, at index position 0 is the value of 2. Something is wrong with that slide, guys. At index 0, let's fix that up straight away because something is wrong there. Haven't made kind of mistakes for a while, but we're only human, so it does happen. All right, so let's try that again. Search pass number 3, here we go. So the value at index 0 here is the value of 2, and that's the one we're looking for. So yay, the search is finished. This one took a little bit longer. This took 3 passes for us to get there. 3 lots of kind of cutting it in half, then cutting it in half again, and then there was nothing left to cut because we were right here at 0 on that number. So on the 3rd pass, we hit it and we finished our search. Right. Now, in this case, hey, look, the binary search wouldn't have been quicker because if you did linear, oh, you would have found it straight away at the first one. That was just lucky, right? On average, binary search is quicker. Now, we just need to do one more example of desk checking because we haven't done anything yet where we've looked for something which definitely isn't in our array. So we're checking out, how do we do a not found if something isn't in the array? If someone types in that they want to look up something, but it isn't in our little storage array, how do we cope with that with our programming? So again, you know, the low index is 0 on this one, the high index is at 9. We've still got those same numbers, 2, 4, 6, 8, 10, the even numbers up to 20. So we've got 10 items here, indexed from 0 to 9 in Visual Basic. We're going to be doing search pass number 1 here. Remember, it came out 4.5, so we dropped off the 0.5 and made it 4. Check out what's at 4, it's a 10. Now compare that 10 with our number 7 that we're looking for. 10 is bigger than 7. So all of these other guys past 10 at index 5, 6, 7, 8, 9, they're going to all be too big, plus the 10's too big. So we need to cross all them off and ignore them and forget about it. And now we can realign things that we're going to need to search from 0 to 3. So this sort of high index now isn't down the bottom. It's going to jump up here to number 3, and that'll set us up for search pass 2. So in search pass 2 here, low index is 0. We've moved our high index up to be where the middle was -1, which is at 3 here. And then we're going to do our adding together. 0 plus 3, our low plus our high, and divide by 2. Low plus high, or high plus low, divide by 2. So we do our 0 plus our 3 here for the indexes. We get 1.5, so we take that down to 1. And at index number 1, we've got the value of 4. Now, how does 4 stack up against the 7 that we're looking for? 4 is smaller than 7, so that means anything else that's underneath here, earlier in the array, because it's sorted, is also too small. So we need to get rid of 4, and we can get rid of 2 as well. So we can get rid of the lower half of that little area we were searching between 0 and 3 here. both of these are duds and we can get rid of them. So we do that. And now we're just left to this little tiny area here. Our high index is still going to be 3, but we're going to have to bring that low index down now to be at this position here. So we can search that last tiny little piece that's left. So in search pass 3, we're searching this last little tiny piece that's left here. So the low index is at 2 and the high index is here at index number 3. And so we add 2 plus 3 together and divide by 2, high plus low, 3 plus 2, divide by 2, 2.5. Drop that down by getting rid of the 0.5 to a 2. What's at position 2? It's 6. How does 6 compare with that 7 that we're looking for? 6 is smaller than 7, so we can get rid of 6 plus anything that's lower than that. So forget about 6, and we're really narrowing things down. We've only got one more kind of box or drawer to open up searching for stuff to see if it is the number 7. And so let's do that in our next pass. So wow, we're up to search pass 4 for this one. The low index is 3, the high index is also 3. And when you do 3 plus 3, add them together, divide by 2, the middle index is also 3. And so we go to position 3 and there's an 8 there. How does 8 stack up or compare against 7? Well, 8's bigger than 7, and so we're going to discard 8 and all of the upper half of the array, which we've already done anyway, because we got rid of all those big numbers. So now there's actually no numbers left, no positions, no boxes, no storage locations to look at to try and find our 7 that we're looking for. So we continue. Now we get to search pass 5, but search pass 5 is actually not going to get fully executed, and we'll explain why. The new low index now, notice how our low index was sort of coming up by 1 from the middle position by 1 again. It'll now jump up to 4, because remember the computer's blind and it's dumb too. It can't remember that it's already crossed off all these ones here. So it'll just keep processing in its pattern here, and it'll go up to number 4. The high index is at 3, and when that happens, once your low index becomes bigger than your high index, that's when you know it's time to stop searching, because you've got a not found situation. So that's really key. That's going to help us end the loop in the pseudocode. So we'll have this loop to keep cutting things in half, looking for stuff. But once that low index value creeps up and gets bigger than your high index, so it's got down below where the high one is, that's when you know it's time to stop and just say, hey, the thing isn't found. So just give the message, number 7 not found. Now, if we think very carefully back across our 3 desk checks that we have done, then we can sort of develop this algorithm. So let's have a look at the algorithm here. So we're setting some initial things up. The search for value, we've got to get that input from a text box on our form. We're just going to set, hey, it's not found yet. Let's just set that to false. The low index, remember, is the first item in the array, its index, and the high one starts off right at the end of the array, down the bottom there, and that's the high index. Then while the low index is less than or equal to the high index, because remember, if we work all the way through halving, when that low one gets bigger, that's when it's time to stop and say, hey, not found. So as long as it's still, the low index is still smaller, or it can even be equal to the high index, that's okay, and we can keep doing our loop here, checking for stuff, cutting it in half and checking, cutting in half and checking. But once that doesn't become true, and that'll happen when your low index gets bigger than your high one, that's when the loop will stop, and we can work out the not found situation. So as you can see here, we had stuff where we were saying, okay, where's our next middle point to check? Add together the current low index plus the high index and divide by 2. We saw that in our trace checking. Then you're always checking the search item against the middle value that you found. So you get your middle index position, but you don't use the index number, you use the actual value that was there on the right-hand side when we're doing those desk checks. If that equals the search value, well, that's when we have a found situation, and we exit the search. So we just do an exit sub in Visual Basic. We get out of this subroutine and it's all finished and we've found the item. Okay. Otherwise, that's when we need to shuffle our high and low positions and chop off, put little red crosses and get rid of half of the stuff out of the searching. So that's kind of the logic that was going on down in here. And you might have to look back at the examples and compare the pseudocode and think about that. We won't try and do it step by step, a trace table or anything in this video, because it's probably getting long enough as it is. So just be careful about the index values. People often get the index value mixed up. They go, oh, I'm searching for the number 23. How's that compare with 5? But 5's actually the index number. It's not actually the value. At position 5 in the array, index number 5, the value might be like 21 or something, okay? So they often get mixed up with the indexes and the values. So that's something to be very careful about doing. And let's get into writing version 1 of our Visual Basic program. So yeah, if you're programming in another language, you can just stop the video here and go and try that algorithm out. Maybe go to the downloads for this lesson, print out the page that's got that algorithm on it, have it printed out in your table and try and code it in your language. This is how we're going to do it in Visual Basic. Anyway, the first thing is to make the well, let's look at the finished program so you know what you're going to be making, all right? So the idea is we're going to have a thing like we did in the Dream Team Tennis Arrays lesson. If you haven't done that, maybe you need to go back and do it if you don't understand this. We've got a thing called a list box here. We click the load array button. It actually reads what's hard-coded into our program and in computer memory, puts it in a list box so we can see it on the screen here. So that'll just spit out onto the screen what's in our array. In this one, we're looking for the value 7. We just decided to type in 7 and click search. And you can see 7 is in there, so 7 should be found, and that algorithm that we've got in the program did actually find it okay. So 7 is in the array. If you use the same bunch of numbers again, the same array, don't change that, and you go looking for 4, well, this is in sorted order. There is no 4 between 3 and 5 where we'd expect it to be, so this should come up and say that it was not found, and it all works okay and does that, okay? So that's kind of it. And if you want just a little bit more of a detailed look, here's the program. The first thing you need to do is click to load that array. Now, if the person just forgets to do that and searches, see how we've got this message box here, click the load array button. So you've got to make sure they've loaded that up. Give them a message. Remember when we did that stuff about good design in a previous lesson? If your application is responsive, it should talk back to the user and say, yep, you click that button and yes, the list box is loaded. Now, if they try search for something, it'll say type in a value to search for. So let's just search for the number, 145, which obviously isn't in our array. Search 145 is not found in the array. Let's try a number that is, and you should try numbers at the extremity. So we should try numbers like 31. We should try something like 29 down near the end there. You should actually try all the numbers in the array. Let's check our clear button works, because we can actually clear things. We need to reload the array. Let's check for number 1, search for that. Yep, 1 was found. We can clear, we can exit, and that is all good. Okay, so that's how the program's going to work. Let's have a look at the form design quickly. You can see what we've got on there. So it's got 3 group boxes. So this is a group box. The text property in the group box has array contents in it. That's how that name comes up. These other 2 group boxes, we just blanked out the text box property. So no name comes up in the corner of them, which just makes them a nice little boundary box. And you put them down on your form first. Then you can move the other items onto the form. So we've just got 4 buttons here, the load array, the search, the clear, and the exit. We've got a label there just saying what to do. This is a text box here where they type into. The result is a label so that they can't type into it. It's also got a background color. It's been made, I think, border property 3D or something like that to get that white around it. But these guys have to have special names. So make sure the buttons, this one's called BTN load list, and you've got to call it that so it matches up with the program code. BTN search, BTN clear, BTN exit, using our Hungarian names of BTN for button. This guy here, the list box, so you just drag out a list box from your toolkit. That is called LST array items. That's your TXT input, just a text box. This is your LBL output MSG, not message. We just made it a little bit shorter by saying MSG. So yeah, some of those have important names. Make sure you put those names on when you do the form. All right, so let's start looking at the code. First thing you need to is define some variables that you're going to need. So we just put them straight up the top of the program underneath form 1, so that way they'll be global and any part of the program can access them. So we have to have, that low number. We've got to have the high index. We've got to have our middle index. They're all dimensions integers here. We've got a value we're searching for, so we're going to grab what's in the text box on the form, put it into this int search for value in our program, check it out. We've got a Boolean flag here to tell us whether we found our value. We've set up our array. Our array is called strnumsList. It's an integer type things which are in there. All the things are integers, and that's the one we're using, the prime numbers, the first 11 prime numbers there, 11 values in our array, so that's hard coded in, so that all goes up the top part of the program. Next bit we do is we set up some validation, because we only want them typing numbers into that text box, not letters and other things. So you need to have kind of looked at our ASCII regex validations lesson, or maybe the password entry lesson had this in as well. So you know how to do key press events and how to use ASCII codes. So what this is going to do, every time they press a key to type in that text box, it's going to check, is the ASCII value between 48 and 57, which are number values in the ASCII table, or is it an 8, which is a backspace character that they've pressed on the keyboard? If that's like that, well, the input's okay. If it's not like that, mark it as handled and put up a message box error to the user. So that should all be familiar from previous lessons, nothing new there. Double click anywhere in the blank part of the form, because we're going to have some stuff happen in the form 1 load event when the form first loads in, and we're just checking out that that button to load the list is enabled. Set it to true, because after the list is loaded we're going to set it to false. Otherwise people can sit there, click click click, and load that list multiple times, which we don't want. We only want our array listed once in the list box. And just setting a couple of other things, doing the focus so that when the form comes up, the cursor's already kind of flashing there in the input box, so the user knows, hey, yeah, I should be typing into there. That's already set at the location for them. That's increasing usability, which is a good form design practice. Then that load array button, which we made on the form, double click on that button and it should automatically generate the subroutine for you that handles, it's an event here but for when they click the btn load list, and I'll put the n sub in. You need to put all this code in between. And this is just the same code we used in the Tennis Dream Team when we did the arrays lesson. So yeah, if you're not understanding this, you probably need to go back to the arrays lesson and have a look at that. But that will just load that program array we had. Let's just see if we can go, where am I going? Up, 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 back. Where were we? We were further back than that. Yeah, remember how we hard-coded this array into the program? Well, where we're up to now with that load is, it's just going to take all the items that were in our nums list and put it into the list box, all right, just using a little loop. So go back to the Tennis Dream Team arrays list boxes searching lesson to check that out if you don't understand it or you haven't done that lesson. Now the btn search button, that's going to have a bit of code on it. This first bit of code, we just make sure that they haven't not loaded. So if the array list hasn't been loaded up, the list box hasn't been loaded up, let's just tell them, hey, click that load array button, put that in the label output message area, and just exit this subroutine so they can't do anything else until they have actually clicked the button and we've loaded it up, just so we can see it on our form. Technically it's not needed, it just makes it nicer for us to be able to see what's in the array output onto the form into the list box. Another one here, check they haven't left the text box completely blank. Okay, so we need to do that. If they have, just give them the message into the label. Right, so in that label on the form, we're just going to have this appear in the label box, and get out of this subroutine. Don't do anything else because we're not ready to go yet because I haven't put in all of the input data. If both of these tests are kind of okay and there is stuff put in and they've done stuff, just set the output area back, clear it all out so it's got nothing in it. And then we continue with the subroutine. So the next part's continuing on this button search routine, and what they've typed in the text box should be a number because we had that key press validation on it. Excuse me a minute. So that should be okay. But we need to convert that into an integer. So remember, casting as integer. We've done that previously before. So what's in that text box? You need to actually cint, which is kind of like converting or casting it into an integer, so that it can go into this int search for value variable in our program. So what was in the text box becomes into a number variable, and then we can do things with it that are number things, okay? And so we're just setting our low index to 0, because that's always the very start of the array. We're setting up the high index. We're looking at how long the array is and taking 1 off it to work out right where the very end of the array is. So this is kind of the first pass, setting up for that. We're just saying, no, we haven't found anything yet because we haven't even done any passes yet. We're going to have a whole separate routine that's been written here to do that binary search algorithm. So that's going to go in its own subroutine down below. Look, you could have put all the code in here, but that'll make this subroutine really long. With the modularization, we're doing at our stage of programming. I think really, you know, if anything's kind of too big to get on an A4 screen print, the module's probably too big and you should look at breaking it into submodules. So anyway, that's in a separate submodule. When it comes back from doing that, after searching the array, it'll either have an answer that it found it or it didn't find it. So depending on the answer, we can put out this value they were searching for and say whether it was found in the array or whether it was not found in the array. And we put that out onto the screen in that output message area. Okay, just a couple more things to do, and that's to do the actual binary searching. So this submodule, the binary search array one that we've called it, if you look at that, yes, that is our algorithm for binary searching, but we've just converted it into Visual Basic Code, all right? So it's always kind of getting the middle in each pass by taking what's your current low one, what's your current high one, dividing by 2, working out that position, going to that position, checking out, okay, what's in that position? Does it equal the value we're looking for? If it does, that's great, true, and we can get out of the sub. Okay, that's what happened when we were looking for that 23 guy on just the second loop. We found it in example 1. But if it's not the case, well, then it comes down in here and it's going to shuffle around those low and high indexes. And by doing that, it's going to also chop out either the bottom half of the data or the top half of the current data to eliminate that and narrow down our search. We start out really big, we go in half, and then we might decide we're doing the bottom half, so we go in half again. Maybe then we decide we're doing the top half of that bit, so you come up a little bit until you kind of get together. When you get equal, it might be found. If it kind of shifts past that, remember, that means it's definitely not going to be found, okay? So it kind of comes down half, 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 might be together, that could be okay, but once they're not together going this way, bang, game over, not found. So just try and remember that in the coding. Just need the clear and exit buttons. We've done those in plenty of programs. So here's the code that's going to clear out things for our particular form screen. And of course, now we've got all of that code in. We're at the end class here, right down the bottom. Yay! So look, get all of that code put into the program, make the form. Pause the video to do that, and you are going to have to do some testing. We'll just show you the testing quickly, all right? So there we are. We've loaded up our array. We were looking for the number 5. 5 is in there. So we did get the message 5 was found in the array. So that test was all good. I've done another test here for 12. Let's have a look at these numbers. No, 12's not one of them. So it should be a not found. And sure enough, it did work, and it said 12 is not found in the array, so that's good, yay. The next one, we're testing extremities right down the bottom here, the last one, 31, putting that in, clicking the search button, yes, it was found, so that's all good. And then we just did a whole lot of tests. We actually tested every single number in that array to make sure it worked, and tested numbers outside, like really big numbers like 502, 99,000 and stuff. Just to really make sure it worked, and tested the clear and exit buttons. So that's what you need to do. Pause the video, write your program with that code we've given you, test it, get it all working, make sure it's working. Then there is going to be a kind of part 2, a version 2 of the program, but get this first one done first. So pause the video, take a break, and do that now. All right, let's take a look at version 2. Now, if you're having troubles, remember, there is the full download for this program. So if you go to the video description, there's a link there. You can actually follow that link and you can get a copy of the full code for version 1. So if your version 1 wasn't working too well, get a copy of the full code, check that out, maybe copy and paste different parts in to get yours working. And all of these versions we're doing from now on, including the challenge tasks, they're all in that download you can get, which is a summary of this lesson, plus all the code. The code comes in the Word document part of the download. The download's got about, I think, 3 or 4 different items that you download when you go to the page. But anyway, look, everything worked fine for arrays there in our first version. Now remember when we tested back with our tracing, our desk checking, we did example 2 and we did example 3 and they had even numbers of items. Remember that's when we were doing like 2, 4, 6, 8, 10, 12 up to 20. We're now going to actually just check out that our program we've written does that okay. So all you really need to do is in your program, just where you've got strnums list, just go and change them from being 1, 3, 5, 7, 11 and all that stuff to just being 2, 4, 6, 8, 10. And when you count them up, there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 values there with the commas in between. So it's just the first even numbers there up to 20. So yeah, we need that set up as the array. And we're also going to add some Debug.Writeline Display so that we can trace through what the binary search algorithm's actually doing. So straight under where in the searching module, where you add in your current low value plus your high value and divide by 2 to get the new middle position in the index. Underneath there, we've just got these things, debug.writeline, which we have shown you before, I think, in the calculator project. And we put brackets, we just write our own writing in here. The and will join on whatever our int passes loop counter is. Okay, now we did put in a loop counter to work out what loop we're in. So you might need to get the download file for this program to check this out fully. Check with your teacher because they should have like the resources for you, your teacher or instructor, because you might not necessarily need to download them yourself. So yeah, we're just putting out what is the value of the low index, the high, the middle, and we're calculating the exact middle for when things are 4.5 and 1.5 and stuff like that. So we just added them in, and they're basically the only 2 changes we made to the program. And so then we ran the program, because remember this was the data that we used for examples 2 and 3 when we're doing the desk check. So we're just redoing the desk checks now with our actual Visual Basic code that we've written. So searching for 2 was example 2. So there's our numbers, 2, 4, 6, 8, 10, 12. They're all coming up beautifully when we click load array. And we're putting in that we want to search for 2, the first value there, and yay, 2 was found in the array, so our program's working. Now those debug write lines, what they do is your program runs, and then underneath there, there's this thing called intermediate window, and it puts a display in there, which is all of the debug write line things. And this is what came out in the display. By the way, if you ever need to clear that display, you just right click in that area and then you choose the clear all, and that kind of clears it out. But what happened here in the intermediate window was in loop pass number 1, we had 0 as our low index and 9. And remember when we add them together in the debug tracing, it was 4.5, and then we took the 4.5 off and made it 4. So that's all worked exactly the same. When we get to loop pass 2 though, something a bit strange happened, because when we were doing the manual kind of working earlier in this video, we added together 0 and 3 and got 1.5, and then we just dropped the 0.5 off and made it 1 for our index position. But Visual Basic hasn't truncated there, it hasn't dropped it off, it's actually gone, oh, 1.5, I'm going to round that up to 2 and make the middle index 2. So Visual Basic seems to be a bit inconsistent. Sometimes it'll drop the 0.5 off and drop it down to 4, other times it looks at the 0.5 and will round it up to 2. Now we've done a whole bunch of testing and tracing and checking through Stack Overflow and all sorts of things, and we haven't found an answer for this. It just seems that it's a bit random, that sometimes it truncates, sometimes it rounds up. But look, it doesn't matter, it always gets to the right answer anyway, so it doesn't seem to be a problem. It's just an annoying little thing. I'd like to know and understand why it's not always working. See, here we had low index on pass number 3 of 0, high index of 1. Add 0 plus 1 together and divide by 2, you get 0.5 as your exact answer, and it's okay there. It's taken off the 0.5 and put it to 0. It didn't try and round it up to 1. So yeah, that's what it's done. And that's what we see. And it gets there okay and finds our number 2, just like it did when we did the manual tracing. Okay, so example 3, we're searching for 7 because I was supposed to give a not found result. So remember, we still had our same numbers, 2, 4, 6, 8, 10, 12 up to 20, but we picked something like 7, I think, back when we did example 3 because that was going to be a not found. And when you check out the immediate window here of our debug trace lines that we wrote in for ourselves, 0 plus 9, yep, you get your 4.5, it drops it down to 4, goes to the 4th position, which is 8, compares 8 with 7, you know, 8 would be too big, so it could get rid of all of that and then just start looking at this bottom area. So it's looking at the low index of 0 and the high index of 3, so 0, be looking at these numbers, 2, 4, 6 in this second pass, loop pass number 2, works out it's going to go to the middle index position of 2. So here it's rounded up again. Instead of just getting rid of the 0.5 and going to position 1, it's gone to position 2. So I would have gone here and looked at the 4 and compared the 4 with the 7. And when you get to loop pass 3, we've got the low, the high, and the middle are all equal to each other. And then you don't get a loop past 4 because it kind of stops and just sets that it's game over and it can't find it. This is a little bit tricky. What happens in the code is that because the middle number isn't bigger than what we're searching for, it goes down here and it adds 1 on to your index value. So it was at 6, that's where it's looking at position 3. It's looking at the 6 and comparing it with 7. It drops down into here, and what it'll do is go, okay, I'm at index position 3. I need to add 1 more and go to index position 4. And when it does that, what'll happen is that the low index at position 4 for the low one's going to become bigger than the high one. This is where the thing drops down, the low one drops down and it's now a bigger value than the high index. And the low one should never be bigger. That's why it's called the low one. It's always supposed to be lower. So as soon as that low one stops being lower than the high one, that's game over, because you could search forever and you're never going to find it. It's a not found condition, okay? The low one should always be lower than the higher. If you're doing your checking and it's not lower than the higher one, or it's not equal to the higher one, then it's game over, and not found is what gets put out. And that's why we use this controlling in the loop. You might have to think about this to understand it, but we're only going to keep going while that low index is actually lower than the high index, like it should be in a binary search. It's actually okay if it becomes equal to it. Remember, sometimes things got to position 0. I think they both got there when we found that number 2 in one of the searches. That was okay. But as soon as that low number, like if that low number jumps down to being index 3 and the high number's at position 0, well, that's all wrong. The low one can never be a bigger value than the high one, and that's when you stop searching and set the not found. So version 2 all worked. So now we're going to get you to make some changes. These are challenge tasks. So perhaps pause the video, write your version 2 and test it. Put in those debug displays if you want to have them by going to the downloads for this video in the YouTube description, getting them. And here's just, I think, 4 little challenges for you guys to have a go at. So look, you might be happy and have spent enough time programming today and not have any more time left. So, you know, the YouTube video, we've got a timeline index, so you can come back and do this challenge task tomorrow or the next day when you've got time. It's up to you. All right. But anyway, the first one is we're just going to change it. Fix up your array so it's got some negative numbers in it. And for them to be able to look for a negative number, though, you will have to change the validation code so that a dash is allowed to be typed in, because at the moment the dash symbol isn't, and you'll need to find the ASCII number for dash and allow it. And then, yeah, that should work fine. You shouldn't have to change the logic of the searching code or anything like that. That should all work for negative numbers. So that's challenge task 1. And it still should work for positive ones like it used to. Still should work for 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That should still work. Challenge task number 2 is to change from integer in your dimensions to doubles so that you can have numbers like negative 4.2, negative 2.1, 4.7, 5 to 4 here. And if you search for one of those decimal ones, it can actually find them. These need to be in sorted order though. Remember, smallest ones, negatives at the bottom, and biggest numbers here down at the top. So make sure you've typed them in across the page in sorted order. That should work. So you can do decimals as well. Now, to do names, names are different to numbers. So what you'll need to do is you go to your top level folder, and we'll just show you this because this is what we did with all of our projects. So what happens is here, let's have a look. So you've got this version of the program, right? There's your solution, there's your bin, debug, all that sort of stuff. This should all look familiar to you. So say I wanted to make another version of the program, I just go Control C and then I go Control V. And this could be, let's just call this Passy or something. All right, so this is going to be version, wow, we're up to 7 here. Version 7 Passy. And then what you can do is, you'll still be able to go off and still do your decimal doubles, still do your negatives ones because they're in separate programs. But this special one we're doing for Passy here, you can double click, go in your solution file, open that one up and change it, and you'll still have executable copies of all the other ones you've made. So that's what we mean when we say the copying thing here. So let's go to where we are. So when we say make a top folder copy all, that's what we mean. Take the one that's finished now, make sure the project's closed down and not open in Visual Studio. Copy that big folder where the whole thing went, and make another folder, rename that other folder, but don't rename anything down below further inside it. And then you can change that one and still have your old one there to run. Anyway, so this one's going to be names. So you'll have to make quite a few modifications. We're going to have a few names there in our array hard-coded into our program. And when you search for one, it should be able to find it, okay? But it's going to do binary search. This is like the search we did in the arrays for the tennis dream team, but that was a linear search. This time it's going to be using the binary search algorithm to do it. And last of all, we're going to do dates. So we're just going to have things like 14/02/2019. So these are Australian dates, DD/MM/YYY. If you're in America, just change that to MMDD and swap these around in the array data you type into the program. So they are just done as strings. So don't put them as date type, put them as string type. And you can also use your regex pattern matching that you learnt in the validation lessons. We were using it for phone numbers to have dashes in between the phone number digits, but you can have right sloping slashes in between, like we've got here between 14 and /02 and /2019. So you can use a regex pattern match on this. So you should do that as well. Okay, so having coded and tested all these different versions, we're very confident, well, except for the 22nd of the 2nd, 2019. We're not confident about that at the moment. But look, this algorithm seems to work. Everything seems to be good. It seems like a great algorithm and must be the correct one for doing binary searches. Further reading, if you're doing the VCE software development course in Melbourne, then you need to look at the Adrian Jansen textbook 3rd edition, the one that has a cover like this, and read pages 85 to 87. You've paid a lot of dollars for that book, so you might as well read it. And those pages are all about binary searching, so make sure you do that, do your book reading. And for our programming course, we just wanted to let you know that, YouTube is where we store all of our videos, but it can be hard to find the videos on YouTube, so you're better off going to our website. So that's at PassyWorldOfICT.com programming. Go there, and let's just actually go there quickly ourselves, which is over here, and click on programming, which will take you here. And this takes you down to the lessons in the order which you should have done them. So we've been talking a lot about the ASCII codes and regex. So that's this lesson here. See, ASCII and regex. So you can click there to go to the lesson. Let's go to the lesson. Wake up, Mr. Internet. Not known for its particularly fast internet speeds here in Australia. And yeah, there's some overviews. Some shows you some of the things we do in the lesson. And then there's a whole contents. This is a monster, really big lesson, lots of contents in here. All of that will be listed with time codes on it in the video description for this, so you can click this and start watching it. You can go click there and watch it on YouTube. You can go full screen and all those sorts of things like that. And then, yeah, there are some downloads you can get for that as well. Okay, so it's best to actually go to the programming list and find things in there. Okay, don't try, YouTube's getting really filled up with videos now, so don't go there. Just go to our programming page, go to the programming link and look through there to find things that you need to know how to do. And what we need to do right now is just finish up this video, and that's what we're going to do. So look, thanks for watching. Hopefully that's going to help you out a lot with understanding binary search and coding it. We'll get to the bottom of that date not working and let you know about that. If it's not an overlay on this video, it'll definitely be in the video description, something about that. Okay, and until the next lesson, it's bye from us and we'll see you then. Subscribe to our channel. We're doing videos every week.